This is the video lesson for Geometry Lesson 1.3, Measuring Segments. The objective of this lesson is to find and compare lengths of segments. So the first thing we're learning in this section is the postulate 1.5, which is the ruler postulate. It's basically the distance between 2 points. So every point on a line can be paired with a real number, and this makes a one-to-one correspondence. This is basically like a number line, kind of just a formal definition of a number line, and how you can use a ruler to measure between 2 points on a number line. And this distance between 2 points on a number line is calculated as the absolute value between the coordinate of your first point and the difference between the coordinate of your second point and your first point, and the absolute value of that, right? You would never have a negative distance. And then distance is written with the between 2 points is the name of the 2 points, just writing them next to each other. So A and B with no line on top, no arrows, nothing. It's just the 2 letters by themselves means the distance. So it actually is a number. It's a length. And we can see this in action with the first problem. So here we have a number line with 4 named points. And each point corresponds to a number on the number line. And the question asks to find the measure of each segment. So the first segment it's asking for is UV, which is this segment right here. What's the length of this? Obviously you could count because it's close enough to count, right? 1, 2, 3, 4. So the answer here is going to be 4. But let's use it with the definition of distance. So if we take, remember the distance is going to be between UV, right? UV doesn't have a line on it, right? UV is just going to be a number. It's going to be the absolute value of the coordinate at U, which is 10, minus the coordinate at V, which is 14, right? And then 10 minus 14 is negative 4, right? The distance isn't negative 4. It's the absolute value of that. So the absolute value of negative 4 is 4. And remember, we got that also by just counting 1, 2, 3, 4. So it's easier. If it's easier to count, obviously count. But for ones that are further away, you're going to have to use this, and so it's important to know. And right now we're going to do it with easy ones that you can count. So what is ST, right? Without a line, that means it's going to be a number. It's a distance. This actually looks kind of far, right? We would rather just do the math and rather than count it. So let's just, we're going to do it anyway, right? So this is going to be, the coordinate S is negative 4. The coordinate T is 8, so we're going to subtract 8. So negative 4 minus 8 is negative 12. The absolute value of negative 12 is 12. And then we can also test it by counting, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You also need to be careful with counting is if they're skipping numbers. So say I didn't put this line here, right? You wouldn't want to count this as 1, right? Because this is going to 2. So just definitely do it with the formula. Okay, and so for on your own, please pause the video and do find TV and then find SV, and then check back for the answer. Okay, so hopefully you did that, and hopefully for C you got 6, and for D you got 18. If not, ask questions when you get to class, or take a look at how I solved these. Push pause. All right, next page. We have a new postulate. It's called the segment addition postulate. So it's saying that if you have 3 points on the same line, right, if they're all collinear, and you have a point that's in between them, then the length of the one endpoint to the middle endpoint to the shared point, that segment, plus the segment of the shared point to the other endpoint is going to equal that whole endpoint, right? And that's kind of common sense, but this is a formal way to write it, right? This plus this equal this, right? Because they share this point here. Okay, and we're going to add in a little algebra with this problem. So problem 2, if EG is 59, so that's saying this whole thing here, right, this is 59. If we know that this whole thing is 59, then what is this segment? And then what's this segment, right? What's EF and FG? So we're going to have to set up an algebra problem, right? This plus this equals 59, right? 8x minus 14 plus 4x plus 1 equals 59. So yay, we get to do some algebra. Exciting. Remember, for algebra, we need to combine like terms. So like terms here are going to be, let's start with the x's, right? This is an x and this has an x. So together, 8x plus 4x is 12x. So these two combine to be 12x. And then this is just a number negative 14, and this is a number plus 1. So we can combine those to be negative 14 plus 1. So we're negative 14, and we can go 1 to the right side. It's going to be negative 13. And this still equals 59. Okay, so here I'm going to rewrite this up here because I didn't actually leave enough space for this. 12x minus 13 equals 59. Okay, remember we have an equation. We're going to put these railroad tracks. So we remember we only do one thing on each side of the railroad track. So you don't want to do two operations. So whatever operation you do on the left side of the railroad track, you want to do on the other side of the railroad track. So in this case, we want to get x alone. So we're going to get rid of this negative 13. So what's the opposite of minus 13? The opposite of minus is plus. We're going to plus 13 on that side, but since we're adding 13 to the left side, we need to add it to the right side. And we have these railroad tracks here so we can keep track of where we're going to be adding 13. So 59 plus 13, 72. 13 plus negative 13 plus 13, that goes to 0. So you still have 12x on this side. So 12x equals 72. And now we want to get this x alone. This is 12 times x. So to undo the 12 times, we want to do the opposite of times, which is divide. We're going to divide by 12. Okay, and so this 12 divided by 12 is 1. Right, so if you write 1x, that's the same as writing x. So now we have our x alone. And 72 divided by 12 is, what was that, 6? Yeah, so x is 6. Okay, that is not the answer though, right? It says, what are EF and FG? But now we have x, we can take this x and plug it into that x, and we can plug it into that x. So EF is equal to 8x minus 14. Since my x is 6, we can go 8 times 6 minus 14. 8 times 6 is 48. And minus 14 is 34. So EF is 34. And then FG, we could also plug in 6 there, right? 6 times 4 is 24 plus 1. This is going to be 25. Or we could take 59 and subtract 34. So here, what I did here to get the 25 is I took 4 times 6 plus 1, right? Because FG equals 4x plus 1. 4 times 6 is 24 plus 1 is 25. Okay, so EF is 34 and FG is 25. Okay, sorry I didn't really leave a lot of room here. So on your piece of paper, I want you to try this one here, right in the diagram, and use this diagram. Rewrite this diagram, or you can just write on your piece of paper. This is saying that this JL is 120. What's JK and what's KL? So try this one on your own, push pause, and then come back and check your answer. Okay, so here we got the answers for JK was 42. And the answer for KL was 78. Hopefully you got that. If not, pause the video and check my work and see if you can find your mistake. And if you can't, or if you still have questions, ask when you get to class. Okay. Moving on. A new vocabulary word is congruent segment. So if two segments have the same length, then the segments are called congruent segments. So congruent uses this symbol here. This means congruent. It's kind of like equals, but it's not exactly equals. It just means two things have the same length, right? So if two twins look the same, two identical twins look the same, right? But they're not the same person. So they would be considered like congruent rather than equal, like the same thing, right? Or two chairs that are identical, right? They're not the same chair, but they're congruent. They look the same, but they share all the same properties physically, but they are not the same chair. So they are not equal, they are congruent. So in this case, this is another way to show kind of how segments are congruent, right? If you have a segment AB that is 1 inch and a segment CD that is 1 inch. Remember, if you write AB without the line on, that's the distance. The distance here is just a number. So this is 1, and the distance here is 1. So 1 does equal 1. 1 is the same as 1, right? But we're talking about the two actual, oh, and I made a mistake here. Check this out, right? This is not congruent to this. This should have a line on it, right? So the line here on top is talking about the actual segment. So segment AB is congruent to segment CD. So they're not equal because they're not the same segment, but they are congruent because they're the same length. And then we can also denote it by putting this little line, this line here. When these lines match, that means they're congruent. So this is saying, oh, AB and CD, they're congruent. They have the same length. Okay, so last slide here. We're going to be talking about congruency between segments. In this case here, problem 3, are AC and BD congruent? So what does congruent mean again? It means they have the same length. So here, AC, we need to figure out what AC, the length of AC is. So we have a formula for that. AC is equal to the absolute value of the coordinate of A, which is -2, minus the coordinate of C, which in this case is 5. -2 minus 5 is -7, so the absolute value of -7 is 7. Again, it's actually maybe easier on for number lines to do the one that's further out to the right minus the one further to the left, then we don't have to deal with the negatives. So let's do that for BD. So BD is equal to, and let's start with the coordinate of D, which is 10, and subtract the coordinate of B in this case, which is 3. And if we subtract 10 from 3, we get absolute value of 7, which is also 7. So since they have the same lengths, then they are congruent. Yes, they are congruent. Okay, so for on your own, please pause the video and try this question. Is AB, segment AB, congruent to segment DE? So push pause, try it on your own, get an answer, and then come back to see if you got it right. Okay, and now you can check your answer here. AB was 5, DE was 4, so no, they were not congruent, right? 4 does not equal 5. Okay, last vocabulary word for 1.3, midpoint. A midpoint of a segment is a point that divides the segment into two congruent segments, right? It's exactly in the middle, right? So if we have a segment AC here, right, and then B would be right in the middle, that means AB is congruent to BC. They're going to have the same length, right? B is the midpoint. And then we have another I guess there's two last vocabulary words here, and this is called a segment bisector. This is a, if L is a line that's going through the midpoint, it's cutting the segment AC into two congruent points, segments, then this line here is called a segment bisector, bi meaning two. So it's bisecting this, the segment into two equal pieces. And we'll have a lot of practice with that. Okay, and starting with the practice here, problem 4. If Q is the midpoint of PR, what are PQ, QR, and RPR? So they didn't actually have to give us any of the lengths. They just are telling us at the midpoints, where the midpoint is. So this means, right, since this is the midpoint, oh, I didn't even write the P, the Q, and the R, sorry. So the Q is the midpoint. Here we go, PR, sorry about that. And then here, the midpoint is U, T, V, sorry about that. Okay. So if we, what do we know about this? If Q is the midpoint, then we know that this is equal to this, right? So PQ is congruent to QR. That means PQ equals QR, right? The lengths. So that means 6x minus 7 equals 5x plus 1. And now we can use algebra to figure out what x is. So this is a little bit different than the algebra we did before. Hopefully you guys aren't too rusty on your algebra. Let's do our little railroad tracks. In this case, we want to get the x's on both sides, right? So this is 5x. That's less than 6x. So let's get rid of that on this side by subtracting 5x. Since we're subtracting 5x from this side, we're going to subtract 5x from this side, and we're left with 1x minus 7, and then there's just equals 1. Okay, now we have x alone on one side. It's not alone yet. We want to get it alone, but it's on its own side. We want to get rid of this minus 7, so we're going to do the opposite of minus, which is plus 7. We're going to do that on both sides of the railroad track, so these cancel. This is x is left now by itself equals 7 plus 1 is 8. So x is equal to 8, and we can substitute that in, right, to here and here and figure out what they are. Hopefully they're the same, because they should be. And then we can add them together to get PR. So let's start with PQ. PQ is equal to 6x minus 7. X is 8, so 6 times 8 minus 7. 6 times 8 is 48, minus 7 is 41. And then let's do QR. Hopefully we'll get 41 for that one too. This is 5x plus 1. 5 times 8 is 40, plus 1 is 41. Yay, okay, that's a good... so this is 41, and this is 41, and then the last question is asking what's PR. So PR is going to be equals, right, 41 plus 41, which is 82. Okay, now try this one on your own. Check back for the answer, and then we are done. Okay, so you can see my work here. Please pause if you want to check your work against that, but the answers are 35, 35, and 70. So TU is 35, UV is 35, and the whole thing TB is 70. All right, your homework for this section is page 25 and 9 through 21 odd.